Hello and welcome to my little release stream. I'm Daniel Stenberg. I do curl stuff during the days. So this is my little presentation of curl 7.69.0. I just released it a while ago, well basically an hour ago now. So I've pushed all the buttons, I've uploaded the packages, I've announced it on the mailing list, I announced it on Twitter, I wrote a blog post about it, and I uploaded it to GitHub. I think I'm pretty much done with the sort of the release procedures. I have a document with all the details that I'm supposed to. I wrote it myself, but all the details that I should follow to do the release. So I think we're in a good shape. So here it is then. Curl 7.69.0. So I have my Twitch chat up here on the screen, as you can see. So feel free to ask questions or comment or do anything, and we can see and go through it. I'm going to start with showing off my blog post on this. I'll just paste the link here just for reference. So this is the blog post I wrote about the curl release. It's basically just expanding a little bit on the change log, or being a little bit more verbose and highlighting some of the what I think more funnier or interesting bug fixes in the release. So again, we do releases every 8 weeks typically if we stick to the schedule, and we usually do. We didn't actually, the last cycle was actually 1 week longer, so the last cycle was 63 days, this was 56 days. So we shipped release, this is release 189 since the beginning. 123 bug fixes counted, and yeah, I added a little blurb, but I think it's still fascinating that we're managing to get help by so many people. So we had contributions, help, bug fixes, bug reports from 69 different persons for this release, and 39 of them had never contributed before. So a lot of newcomers and newbies in the project. I think that's cool. And 32 authors who actually wrote patches or code that we merged into the code repository. 15 new ones. So 15 first-time committers in a single release. Pretty good. So, and I could possibly highlight also the fact that there's not a single security fix in this release, which of course is a yay, because that means that we haven't got any reported and we haven't fixed any, and that's a good thing, right? But, well, it could also be that we haven't had anyone actually look at it careful enough. So I just wanted to maybe jinx everything a little bit and say we do offer cash rewards for security problems in our bug bounty program, and it's been a bit silent in there recently. So I of course view that as something positive. It means that we're actually getting most of the easy ones solved, and there's no obvious security problems in there. But if you're into security and want some USDs as a reward, go dig and find security problems and report them to us in our HackerOne bug bounty program. So yeah, here's the blog post then. So no bug bounties this time, and we did basically 3 small changes this time. Well, what I call changes. We dropped support for the Polar SSL TLS library. So we're down to 13 supported TLS libraries now, and Polar SSL is basically nowadays an unsupported library. It was pretty much replaced by its sibling called Embed TLS. So if you previously used Polar SSL in something, most users have switched over to some other library, or at least Embed TLS. And curl supports Embed TLS also since a long time. So we just basically dropped Polar SSL now because it's an unsupported library that hasn't been updated. It's not going to be updated, it seems, and it's basically just stalled in its development. So we won't encourage our users to keep on using that for anything in production. So switch over to another library if you're Polar SSL. If you still use Polar SSL, you really shouldn't. So you should switch over to something else. I of course say that you should use Wolf SSL. That's a good choice, and as you can see up over there, I actually work for Wolf SSL, so you know I'm biased, but you should consider it. So we dropped Polar SSL. That's change number 1. Change number 2 is that we, well, it's a really minor thing, but we added a little SMTP feature. So now curl supports SMTP. Who knew? It's actually supported it since I think 2006. I don't remember, but for well over a decade at least. So yes, you can send emails with curl, and it works pretty good. But we had this little annoying flaw that you could, you know, when you send an email, you can send an email to many persons, so you can send to a whole range of different email addresses. But in curl, it would return an error if any of those receive addresses returned a failure or an error from the SMTP server. So you basically send to these 10 people, and 9 would be okay, and the 10th would return an error because of some problem with the receiver address, and then curl will say error, and that's not what you typically want when you send an email. You want to have, sure, if one fails, that's fine, but you can still proceed and send to the other 9. And so that's basically what this new option does. It allows a user to say that it's okay to fail as long as at least one receiver is okay. The others may fail, and you can still continue and send the email. It's actually a pretty minor thing code-wise, but still, it's a very old known bug that we finally fixed, or I don't remember exactly who did it, but I think it was a first-time committer. So I think it's sort of a yay for someone to stepping up and fixing that old thing, and it's good. And of course, the third change, we introduced this because in my blog post I call it SSH++ and TLS-, even if WordPress, stupid WordPress destroys my topic, so it doesn't really look like TLS-, it looks like TLS-. Anyway, so the SSH++ means that we added another SSH library for the SSH backend. So now we support 3 different SSH libraries, or 1 out of those 3 it's supported. So now it supports building and using Wolf SSH for Sftp transfers. And that is also a new thing. It doesn't support SCP transfers yet, at least, because I figure that maybe users who want to go that route want an even smaller footprint. So I'd save this SCP transfers, and I'll see. So there's support for Sftp transfers with the Wolf SSH backend. It's actually not totally completed yet, my integration there, but you can use it, and you can use it especially with password authentication, or what's it called? Keyboard, it's called in SSH lingo, isn't it? I don't remember, but it's not called password, it's called something else. Okay, so yeah, those are the 3 changes. Really minor, and most people won't care, so it'll be, yeah, sure, another bump on the road, and curl is another iterative step forward. But I also then, I'm possibly even more happy with some of the bug fixes. So let's take a look on some of the more finer things we improved in this release. And one of my favorite ones is is my bug fix. I've changed the SOCKS proxy connection procedure to become non-blocking, which that might sound like a weird thing, but well, libcurl, the library, has a multi-interface in which you can do many parallel connections or transfers concurrently or simultaneously. So you can fire up and do 5 transfers at once in the same thread. And then it's very important that all transfers are done completely non-blocking, so that not one of the transfers could sort of starve out the others. So if you do 5, you don't want one of them to be having a blocking behavior, because then that single one would starve out the other 4 while it blocks. And that's exactly what curl did for SOX proxy connections up until now. And what I mean with SOX proxy connection is when you connect to a SOX proxy, that connection phase, which of course in most cases is a really quick and swift procedure, and it just happens within milliseconds and you move on. It doesn't affect you. But if you would connect then to a slow SOX proxy far away, perhaps that could seriously impact your application. If you would have a large amount of connections and you would all connect to slow SOX proxies, it would seriously hamper your application's performance. And now it doesn't do that anymore. So I basically rewrote the entire SOX connection thing to be state machine driven and waiting for everything correctly. No, we don't have tests for testing for blocking because I don't think it's not that. I mean, I think it's in the known bugs document or somewhere. Somewhere there's a small list where we mention where we still have blocking behaviors. So there are a few points in the libcurl API that's actually still blocks. So no, we don't have tests for that, but it's sort of an ongoing process to make sure that we over time remove all of those tiny blocking things. There's I think one of the currently still existing worst blocking parts in the. I'm replying now to comments in the Twitch chat. So one of the worst offenders still for blocking behavior, I think, is when you remove a connection, when you remove a transfer that has one of these ping pong protocols like FTP and POP3 and everything, when they actually have to do a command and response interaction, and you might want to do that when you remove a transfer, and it might actually block for a while. There are a few others too. But as I said, we should and we are fixing those flaws as we proceed, and there are some problems with the API that makes it really hard to do it for some of the cases, but it's fine. So that's the SOX connects are non-blocking. We also improved the alt service parsing. It turns out, the alt service header is the header where basically a server responds and says, hey, my service is also available on this other host using this possibly other protocol version. In practice, this is how servers will upgrade to HTTP 3 from HTTP 1 or 2. So this is where people are starting to experiment with curl's alt service support and trying out how do we upgrade to HTTP 3. And then, of course, it turned out that my code was crappy, so I had sort of misunderstood the spec a little bit. So we had to fix the parser a little bit, and now we parse the alt service headers a little bit better. So now I think we work better with, if you go to a random, well, you won't find many HTTP 3 servers out there, but some of them that actually exist now, and they have alt service headers to upgrade, and you can do that with curl now, and I think it works pretty good. I could also then just mention that we're now supporting HTTP 3 draft 27, which happens to be the current one. It was released last week, so we're pretty much in sync with the bleeding edge HTTP 3 drafts. And of course, we didn't do much of that. We depend on the ngTCP2 library and the quiche library, and they're very much on track with the development. So the only thing we must make sure is that our alt service parser knows which draft version we want, since these servers use that draft version in their alt service responses. So, okay. And then talking about alt service, then in the alt services code, as well as the cookie code, we can actually save files, right, to disk for later use. Like if you want to run the curl command line, you can save the cookies to a file, and then another command line invoke to use the cookies from the previous invoke. And in this version, we introduced atomic saves for both cookies and alt service cache, which basically means that if you use curl multi-threaded and you would, for example, save to the same file name or read from a file name another thread would create. Previously, you could then get partial. If you would read from a file that another thread would create, you could get a partial file while the other thread was creating it, and you would read it in another thread. So you would end up with a weird state or a sort of inconsistent state. But now we changed the saving procedure to make it atomic, so the file won't exist until it's done, because we're basically rename it to the final file when we're done with it. So this should make it better in a multi-threaded or even multi-processing case. The file will either not be there or it will be complete. Just a little tiny detail. Of course, it makes the saving procedure a little bit weirder, because now we will save the file in the file name dot random hex letters, 6 of them, dot tmp in the file until it's done, and then we will rename it to the actual file name. Right. So we also, I struggled a bit to do this improvement to the HTTP. Again, back to the libcurl case. When you write an application with libcurl, you pretty much do ask for transfers, right? You would, in the multi-interface case, you would perhaps do X number of parallel transfers, and you would download them to your local application. And sometimes something in your local system makes it that you can't really deal with the incoming data as fast as it can deliver it. So you can tell curl to, hey, pause this stream for a while I sort out my buffering or do whatever, and then resume the transfer again. And we really didn't do that very well for HTTP2 streams, in case there are other HTTP2 streams going on over the same connection. So basically we can have, X number of streams over the same connection, and then we would say pause on one of those streams, but the other streams on the same connection would still go on. In HTTP2 land, of course, you fix that by the windowing system within the HTTP2 protocol. So basically, we say to the other end, we don't give you more buffer room to send data, so please stop sending after you've filled up this window. And previously we announced a huge window, like 1 gigabyte window, so just tell the server to blow it all away to us, so we couldn't really pause it at all. Now we've decreased that window to 32 megabytes, and now in case of you pause it, curl might have to cache 32 megabyte of data, but it's still better than 1 gigabyte. So now you can actually pause an HTTP2 stream, and it'll actually correctly pause it and possibly cache up to 32 megabyte in memory. If this is a problem for your use cases, please speak up, because I think we need a way to possibly reduce that 32 megabyte for particular use cases. But I really couldn't come up with a way to do that dynamically for everyone in a really good way without sort of hampering performance for the ones who don't need it that way. So it's a little bit of a we'll see about that. I've talked to a user who uses this particular thing, who actually had this problem. So I might get some feedback there and see if we need to do some further changes on the windowing things of HTTP2. And HTTP3 pretty much works the same way. So I think this could be transferred into the HTTP3 realm later, or so on. The HTTP3 implementation is still, experimental, and it's not complete, so we still have room to wiggle there. So HTTP2 pausing now works. Another little thing, and well, we're really into HTTP protocol land in this release. We fixed other things in HTTP protocol, and now back to the old HTTP 1 land. So there's this header called expect. I also actually blogged about this expect header separately. You could go there to that special blog post about the expect tweaks. So expect is a header that is generally abused and not understood, and it's a really sad situation for HTTP 1.1. So basically expect says you send that as a client to the server and say, hey, I will send a HTTP request body as well. Is that okay? Send me 100 and I'll go on with it. An HTTP response then that says 100, and the server would just say 100 as a first response, and then the client would go on and send the body, and the server would say 200 in the working case. So curl sends the expect header, and nowadays it sends it slightly differently. Previously, we sent the expect header by default if we knew that the request body would be larger than 1 kilobyte, or if we didn't know the size at all. And now we've changed this. Now we send the header only. Now we send the header only if it's larger than 1 megabyte, or we don't know the size. So this will make curl use the header much less for regular small posts, for example. And this, of course, is because so many servers and other proxies and everything, they basically don't implement this header. So curl has to just time out. It times out after a second. No, 100, continue, ride. We move on anyway. So by increasing this to 1 megabyte, it'll happen much more seldom, and it'll be less of a problem. And also, during this time, since we introduced this limit until now, of course, everyone has higher bandwidth and everything is faster. So nowadays it actually makes more sense. So it's not such a big of a waste if we send a little bit of data and we have to send it again, which is basically what this tries to avoid. So even if we don't manage to avoid it, we won't be that terrible. And at the same time, I also implemented support for the HTTP 417 response, which is the server's way of saying, hey, I didn't want any expect header. Please resend this request without the expect header. So now curl can do that. So if the server actually sends back a 417, curl will just replay the same request again, but without the expect header. I don't know why I haven't really implemented that before, because it's not that complicated in curl side-wise, but I think the primary reason might be that very few servers or server-side implementation actually responds with the 417, so it's a very rare case. Usually they just ignore that and just curl will time out, or it'll say, hey, I didn't understand it at all, and send something other crappy back. Anyway, that's a little bit of a better HTTP implementation in curl, and if anyone wants to say that HTTP is a simple protocol, we can have a discussion about that too. It certainly isn't. And then of course there are a bunch of minor things in the releases, in the release notes or changelog. One of the particular ones, of course, is so 123 logged bug reports in this release. A lot of them are documentation fixes and other smaller bugs. And this, I think this is an example of one of these. We have this feature in curl when you can ask for another libcurl API. Basically, if you connect to a TLS based server, HTTPS or one of the others that are based on TLS, you can also ask curl to return a lot of information about the certificates, or the chain of certificates from the server actually. The option is called curl info _cert info. You get it with curl easy get info. That's a function so that you can extract this from after a connection is done or a transfer is done. And it was kind of ridiculous because it had a limited buffer for one of the informations that it could extract, and it had a limited buffer that made some cases it would cap the string and then return the entire thing, so it would come out just incomplete. And now we've changed that so that it actually doesn't have any that limit anymore. It doesn't have any of that limit anymore actually. So now it'll return data better, just another smaller, thing. One user discovered this. I bet nobody else has done it, so it'll take a while until anyone actually appreciates that. Steve Holm worked a lot on the SMTP support for UTF-based host names in IDN. If you use international domain names and you want to send SMTP with curl, again, curl can send email with SMTP. So, but if you wanted to do that and you had your domain using weirdo international domain names, I say weirdo because they're weirdo. So curl had problems with it, and Steve fixed a lot of the issues with a bunch of those SMTP commands, and now they should work better. There are still some issues, especially on Windows if you want to send them, because on Windows, especially if you use the command line on Windows, because on Windows the character set you're getting in your command line is bonkers. So yeah, there are still things to do there, and there are more PRs coming, I think, from Steve on that. That's Windows. I don't know Windows. In other areas, so libcurl as a library, of course, has public headers. They're actually in a subdirectory called curl. So usually when you install curl, they're in user/include/curl, and then we have a few files in there. A typical curl application that uses libcurl only includes a single header called curl/curl.h, which is convenient. But all up until now, actually, some of the defining of symbols within that header actually defined headers that were not prefixed by curl or libcurl, which is a rather big no-no, and you shouldn't do that in headers, because it makes it, there's a risk that it would collide with other headers that would do that big no-no. So a proper header that is for the public consumption should make sure that you're using the proper name scope, so you would only add or change symbols within your prefix to really minimize the risk that you would collide with someone else, or another library, or another header, or another, so on. So I really made an effort this time in this release to make sure, I actually added a test for this, so it actually makes sure that all the defines and symbols we add in the headers are within our name scope correctly, and hopefully we will discover automatically now if someone accidentally violates this rule. But I think there was in general a good fix. I've also fixed some other things in the library part of things. I blogged about it separately, about my changes to the global init function. So curl global init is a function in libcurl that you, as an application author using libcurl, you have to call it in the beginning. It's documented, not thread safe, so you have to call it first and then use curl for everything you want to do, and then you call curl global cleanup when you're done, and everything is fine and dandy. But the problem here is that curl global init is not thread safe. It's documented as not thread safe, and in this little this link I posted is another blog post of mine that I went into detail why it's not thread safe and what we can or should and want to do to make it thread safe. I did two little things in this release sort of to make on the road towards thread safety in that function. So I made sure that curl nowadays have the EINTR, it's sort of EINTR flag behavior by default. So that means now curl will interrupt loops if it gets interrupted by a signal, which previously you would ask curl to do by a flag in the curl global init function. Nowadays curl will then assume that flag by default to avoid having a global context where that information is stored. And then I did another little thing that I fixed also, how we check for IPv6 functionality in curl. Previously I would do that globally and just say, does it seem like, can we create an IPv6 socket or not? And remember that information and not try, if it doesn't work, don't try IPv6 at all anymore. I'm not sure this is really important, but at least back in the day, I mean a decade or 15 years ago, so it was fairly common that Linux systems actually had IPv6 availability. If you checked for the functions and everything, and the headers, and they were there, but when you tried to create a socket, it failed. So basically, it didn't actually work. So that's this little check. It still exists in curl, and now I moved it so it's not done in a global context. I moved it into a context for the multi-handle. So when you create a multi-handle, it'll do that check and remember there instead. All in an effort to remove information kept in a global context, because a global context is not thread safe. And again, I blogged about that thread safety thing for global curl global init. I hope, and I actually got some really good feedback on that blog post, and I have posted an email about, I have 3 pull requests in progress now to fix those 3 remaining issues for curl global init to make them thread safe. And they will be thread safe at some point, but under certain conditions. So they won't sort of be unconditionally thread safe, but I think it's still a really good step forward. And I really, well, I haven't landed those pull requests yet, so I really can't guarantee that they will happen that way that they're planned to. But I think it's looking good, and I'm hoping that it'll stick and land approximately like those pull requests, because then we have fully thread safe curl global init coming up soon. And why is this important? It's not that important to most users, because most users won't see it or be affected or care, but there are use cases where it is important, and those users will be happy, I hope. Right, and I could also then just mention that as a sort of the last thing I mentioned here in the blog post. First is that I think this is the first release we actually, so the first cycle we actually put a lot of CI jobs on Azure. So there are a lot of good CI, free CI offers these days. So a lot of systems offer free CPU for us, so we try to use all of them as much as possible. So now we can sort of distribute our CI jobs on as many free CI services as possible. So now we're using 5 different ones. So ideally we distribute our CI jobs on all these 5 ones and can use them to maximum amount. And Azure showed up, and they are actually a pretty good CI service here. So we've moved some Travis jobs and added a lot of other jobs, CI jobs to Azure. And Mark Hersken moved all of his Windows jobs over to Azure. So now we're using a lot of Azure CI jobs, and it's good. If I did see an improvement using the new CI, yes, as you can see, that's Mbak. He's the one doing all the work on Azure. So yeah, there are actually many good things with more CIs. First, we get more we've actually, I mean, looking back a little bit, we've done a lot of improvements on the CI just over the last few months, right? We're doing much more torture testing now, which is a really finds a lot of things, and we got that going really good on Azure. We're doing a lot of more Windows tests on Azure. We're doing we have nowadays we have a really nice test panel with test results going on Azure, and I think that's going to be improved more. And just a week, 2 weeks ago, the OSS Fuzz project, you know, the Google one that keeps on running fuzzing on open source projects by some criteria. They run fuzzing for us at least. So they run fuzzing on curl code non-stop all the time, you know, on Google infrastructure, lots of servers doing a crazy amount of fuzzing and that's an awesome service. And nowadays they actually provide another service called CI Fuzz. So we can actually fuzz curl code using the OSS Fuzz infrastructure in every PR and commit we do to curl as another CI job. And that's also another excellent addition. So a little bit of OSS Fuzz fuzzing on each PR. It improves the CI jobs as well. So in general, I actually have a graph somewhere showing the number of CI jobs we have now per commit over time. And it's actually ridiculous. We have, I think we're on 72 different CI jobs now per commit or per pull request. So it's actually becoming quite good. Of course, the CI jobs only tests what we have tests for, so there are still areas where we miss things and we still land bugs, of course, that we shouldn't have. But we are improving, and things are improving. We still have a lot of things to improve in the CI, and we are going to improve more in the CI. Mark is working on tracking down. We have some annoying Windows glitches in the test systems in the CIs that are the most apparent on AppVeyor, but we've seen them on Azure as well. So those, for example, and right now we have this. I said we're using 5 different services. Where we originally used a lot of Travis CI. We still use a lot of Travis CI, but over time Travis CI has turned out to be the most slow and ineffective ones of the ones we use, and nowadays we keep waiting for Travis all the time. So maybe we should try to move over more work from Travis to the other services to even out the load, so that we get more use the other ones more. Or possibly try to get Travis to sponsor us more and up the number of parallel builds we can do on Travis. CI is really the way we make sure that curl is as good as it is when we do more releases. So yeah, that's about it. That's 11 bugs fixes that I mentioned that we did in this release that could be interesting to highlight, where I thought that when I wrote the blog post. We of course have a lot of other things. Perhaps if I would pick out some others that I didn't mention in this blog post, is that we for example, the CMake build got a pretty big revamp and polish by some good contributors who are actually into CMake. In general, our CMake build suffers from not having that many CMake interested people involved, so the CMake build is always lagging behind. So it's good to have these occasional revamps and sort of catch up with how we do things in the configure AutoTools land, and now we can do more of that in the CMake land, because for some reason some people seem to prefer to do things with CMake when they build curl and use that in their projects. What else did we do that I should mention? Well, I think I basically added most of it already. If you want to have a real look at the changelog, just hit the link on there and follow the links. I try to make a really big effort to make sure that we link to all the changes to the relevant issues or pull request where we did or discussed the bug or did the fix. So there's a lot to read up on if you really want to know all the details. We have a lot of more things coming, as always. I think in this particular release, we really had we had a sort of a rush the last few days to get things going, and some things didn't really go, so we had to pause a few things, revert a few things, and of course they're now basically pounding on the door, wanting to get in again. So we're going to start landing more things that didn't really meet didn't really get the time to land properly for this release, but we're going to get it into the next one. So we have a whole bunch of PRs basically waiting. I'm pretty sure there will be changes, so changes in the way that we bump the minor version number in the version string, so that the next release will most probably be 7.70.0. And but it hasn't been completely decided yet. We'll see what people are bringing. I'm actually I don't personally have any really big project to land for the next release myself, so I need to go over and see where we are with all the bugs right now, and decide what to work on for the next release. I should mention, as I said before, over here, the logo up here, I work for Wolf SSL. I do commercial curl support. So if you or your company need help with your curl stuff in your applications or your devices, get in touch and we'll get everything going. Some of the work I did for this release have been things that I did as part of my support contracts with customers. And I think it's a pretty awesome way to improve curl for everyone's benefit, and particularly for the benefit of those who actually paid me to do it. But everyone can sort of get the bug fixes and get the improvements anyway. So what is there to say more? I tried to see so there's this counter here. Currently 0 of the listed downloads are of the latest version. I have a script that actually goes over and checks for updated packages every now and then, but it runs twice a day, so it hasn't updated yet. So it still says there are no updated versions on the download page. So the download page is still pretty bare. They're actually listed in yellow if they're of the latest version. None of them are. Only the source tarballs. I provide 4 different versions of the source tarballs. I don't really know why I provide all the different versions, but you can pick the one you like the most. They have the identical content. They're basically just different compressions. And for some reason, people download all of the different versions, so it's easy to provide all of them. So yeah, they're there. Pick the one you like. So, any questions? Should I just go on and yap about anything? The next curl release is planned to happen on April, what is it? April 29. So that is exactly 56 days from now. We keep on doing the releases every 8 weeks, as long as as long as the release date doesn't land on an unfortunate date, like if it happens in the middle of the Christmas week, or if it happens in the middle of my vacation when I'm traveling somewhere, then we tend to move it back and forth a full week. But it's not. It doesn't look like that this time. What else is there to say about next release? I'm going to do a tiny curl release within a day or two. Tiny curl being my separate little effort to make sure that we can build a really tiny curl for, especially for embedded systems or real-time operating systems. In particular there I have a dedicated port for FreeRTOS, which is not in the standard curl release. It is also partly because I'm experimenting with doing things slightly differently for commercial users. Anyway, so if you're interested in tiny curl and running curl on really small devices, that means devices that are too small to run Linux or too small to run any real operating system, then talk to me and we'll make sure that you get tiny curl running on your RTOS. That is it. I haven't streamed for a long time. I did it before, and I think I'm going to try to get back to it. I also did my video libcurl tutorials that I'm slightly behind on, so I have more video and streaming sort of to do. And if you enjoy this, let me know. If you have any questions, do fire them away. You can find me on Twitter, and you can find everyone on the main. Preferably when you ask curl questions, especially if it's libcurl or development curl, you ask on the curl library mailing list. If you have questions on how to use curl, the tool, you ask on the curl users mailing list. If you have problems, issues, bugs, you file them on GitHub. If you have patches and want to fix code or update documentation, you provide pull requests on GitHub. HTTP 3 in curl is the current code already supports HTTP 3, and you can get curl, you can build it to run HTTP 3. We've supported it for a good while already. So HTTP 3 is marked as experimental in curl, and we don't guarantee that it will remain functional exactly this way when we unmark the experimental thing, just to make sure, just to leave us the freedom to actually change how it behaves so that we can get early experimental code in, and we can work out the quirks and kinks and everything and see how it works, and everyone can work on it and start getting a feel for it. But HTTP 3 is really it's a big ship, and it's really it's a house of cards that where the foundation cards in the bottom, it's really shaky, and we've been a lot of things on top, and a lot of the cards in the bottom, they really are still shaky. So I mean, the spec is not there, so we're on draft 27 spec, so it's getting closer. But even in this draft 27, the Y format was changed again on the protocol, so it still changes. Who knows how many more draft versions there will be? Ideally, hopefully, possibly, not that many, but there's going to be more. This is not the final one. There's an interrupt. There's another quick H3 interrupt next week. So hopefully that'll show that everything is still going in the right direction. But then, of course, there are basically just a bunch of test servers, and basically no one is actually hosting any content for real. Facebook does. So if you want to try some real content over HTTP 3, you can go to Facebook. Cloudflare does too, so you can get some Cloudflare content over HTTP 3. And then we have this weird TLS situation, so you can't build HTTP 3 support with any of the normal standard TLS libraries like OpenSSL or the other ones that you're used to in your Linux or BSD distros. So that's the situation that really needs to be solved, and so basically, I could go on and on about that, especially since OpenSSL said they won't ship any quick support until after 3.0, and 3.0 is planned to happen, was it Q3 this year? Anyway, end of the year 2020. So there won't be any quick support in OpenSSL until after OpenSSL 3.0, which basically means possibly early 2021. So it's a long way off. So if you ask me, curl supporting HTTP 3 will be experimental for quite a while longer. I mean, you can build it and support it and run it if you want to, and you can do it, I mean, ship it yourself too if you want to. But until it actually becomes shipped in a distro or shipped by someone who actually wants to maintain it. Yeah, well, there are a bunch of TLS libraries that support the quick APIs, right? So Boring SSL and some of the other Pico TLS and some of the other smaller TLS libraries. So it's not that difficult to implement the particular quick things if you already have a TLS stack. A TLS stack is in itself, of course. How hard can it be? Yeah, I think a TLS stack is quite hard actually to get right, and it's important to get it right. So we'll see. I've seen that GNU TLS is about to provide the necessary quick APIs, so maybe GNU TLS is the way forward to get quick and HTTP 3 into curl slightly faster than OpenSSL. I don't know. So and then of course we need the specs to actually finalize for this to happen, and some servers to actually use it, and we need to have the quick and HTTP 3 libraries to get some sort of stable situation. So and then we need to figure out how to do things properly in libcurl, and then we need curl to use that. So there's a whole chain of different things that need to fall into place before we can see anyone actually ship curl with HTTP 3 support for real. But until then, I really encourage everyone who want to play and try out HTTP 3 to enable that in curl. It works and it's there, and it'll only be good for us if more people tried it, used it, and sort of got a feel for it, and we could improve where it fails and make sure that so that actually by the time things start to fall in place, we know that our code is there and works and is fine and dandy. I have my outstanding little work issue is to fix multiplexing for HTTP 3, because that still isn't done properly within curl. So when we set up a new transfer over to the same hostname, we could multiplex exactly like we do for HTTP 2. We should for HTTP 3 as well. But then again, it goes back to that we're still in early days. So I've talked to. So when you build with HTTP 3 support with curl, you can build with either using the quiche library or you can use the ngTCP2 library. And both of them are basically lacking some API support that I want for proper multiplexing. Well, I can possibly live without that, but I've talked to both of them about providing those API things so that we can do better multiplexing support, or proper multiplexing, the same way we do for HTTP 2. Well, if someone wants something added to curl, you would, of course, if you want to make really sure it gets added, of course you do the work and you provide a pull request. But providing a pull request for something to curl is of course not a guaranteed way for us to accept it, to say, hey, just let us just merge this and everyone will be happy. But so if you provide, you as in any random person out there would provide a pull request for a new protocol to curl, it would have to match a few things. You have to be sort of I think the protocol would have to have a URL specification. It would have to be curl works with URLs, So there has to be a URL specification, and it has to be a URL specification that possibly someone else could use or so interoperate with, so that you could actually, you know, copy and paste that URL from between applications, and that it could have at least a good theoretical chance of working. That's basically the idea with URLs, right? So that's what curl works with. So if there's no URL spec for the protocol, so that's been suggested before, and people make up their own, so they sure, we can make up one, but it sort of takes away a large point of URLs, and it's not what we're working with curl. And then also, but perhaps the most, I think the biggest criteria for protocols in curl is that can we view the protocol as a transfer related or transport oriented protocol? Can you view it as an upload or a download? We support telnet in curl, which is really one of the worst protocols for curl to support, because it's neither upload nor download. It's more of a session protocol. We shouldn't have implemented it, but okay, nobody's using it, so it's pretty easy to just have it there. But it's really a crappy match. So if someone would come today and say, hey, we should support telnet in curl, I would say, it doesn't really match this transfer oriented view of life that we have in curl. So everything in the APIs and sort of the view of the world we have in curl is that we do transfers, we do uploads, we do downloads, possibly both at once. But if the protocol isn't upload or download, it doesn't really work. So the APIs are really not suitable for anything else. So maybe if you have a protocol that isn't upload or download or both, then maybe curl isn't the place for that protocol. Maybe you should do that protocol somewhere else. Yeah, you can still use the curl, the telnet protocol. So it is usable, but it's still quirky, and it's not a good match. But all the others are actually sort of people that come to about IMAP or SMTP or stuff. But they're actually I think they're very well suited for the curl mindset, right? Because IMAP, that's just downloading data from a server. It just happens to be a mail. SMTP, that's just uploading data to a server that it just happens to be a mail that you send, and stuff like that. So they map really well to the curl way of doing things and the libcurl APIs and everything. Well, X modem, Z modem, then they could have failed the first requirement. There's no URL specification for them because they're not internet transfers, so you can do that anyway. It is interesting to see what people are using. Let me see. I have this, Palmer here is we do these annual user surveys, and there will be another one in 2020, maybe in a few months. So when we ask users what protocols do you use and how often do you use them, where are you? So here we can see most users that respond are European. But anyway, so the question is then what protocols do you use with curl? And if you would look at the top 7 protocols, they're here. Basically, HTTP and HTTPS in the top here. Almost everyone uses those with curl. No big surprise. They're the biggest protocols, I think, even outside of curl. They're really the biggest protocols of the internet. And then the other ones are still HTTPS, HTTP, FTP, FTPS, SFTP, file, and SCP. I think it's interesting that so many people are using curl with file, because it seems like it's sort of unnecessary to use curl to do file transfers, but I guess it's because they like the URL thing. But anyway, Gopher, down here, Gopher, 2.8% of the users, and again, 2.8% of users, I don't know, 2% of the users who responded to the survey said that they're using Gopher with curl. So, and as you can see, it's actually then 5 other protocols below, or actually 4, because POP3S had the same. So 4 protocols are actually less used than Gopher. And you could possibly then say that everything that is sort of below 5%, maybe that's, you know, from IMAPs and below here, maybe they're really not that well used. Maybe, but, you know, I also have this problem that when I ask users, like, sure, do you use curl with some of these protocols? Sure. And one user would say, yeah, I use it, but that user could possibly, you know, run his script 200 million times a day and use half the internet's bandwidth for that particular protocol, and it still counts as only as one user in my survey. So I don't know. Yes, you can download streams. RTMP is supported, but RTMP is a yucky thing. So I wouldn't count on RTMP for anything. It's pretty much like RTSP2, yucky things. Yeah, sometimes I think they're, you know, the web browsers are in fortunate positions where they can have the luxury of getting analysis, sending back home how much, what are people doing, what are users wanting, what are their sort of, you know, to get a sort of feedback. But we're not in such a luxury position. We can't get that information from anyone, so we have to ask users every year. And of course, asking users is a really, I mean, that's a very self-selected bunch of people, right? Only the ones who actually are very, first they need to care a lot about curl to even bother to answer, and they have to know that we're doing a survey, and they have to get that. So yeah, it's hard to reach out to users for real, because I'm convinced that we have the vast majority of users we have, they never bother to answer to any surveys we do. So we don't really know. We know what people respond and what they say they use, and that's the best we can do. I'm also always a bit worried about, I mean, are the users we ask and they say this, is it really true? Or do they say this because they want it to be true, right? I better say that we're using Gopher so that nobody removes Gopher, or stuff like that. Like I have this question further down in the, this is also fun. How many protocols do you use in curl? So you can see that actually more than half of the users are actually using more than 2 protocols. But anyway, I had this question. My favorite questions somewhere in here is, do you use Hdpe pipelining with curl? And a lot of people say, yes, we do. And that's particularly interesting since we removed pipelining support a while ago. So no, you don't really do that if you're using a modern curl. But it's more like, do people really know what pipelining is? And how do you know that you're using it? I've always suspected that people don't actually know what pipelining is when they say they use pipelining. So pipelining in Hdpe, no, you don't use it because it doesn't work in curl since several versions ago we removed it. And even before that, it was really not working very well. So if you used it, you pretty much knew, because it would break in mysterious times every now and then. Right. People are using curl on Linux primarily. See, 93% of what users use it on curl. Just on 93% of curl users use it on Linux. And of course, Linux, Windows, Mac, no big surprise, the biggest ones. But the fun thing is that Android is number 4. Yeah. But this is the survey results from last year. This is interesting. Which Windows versions do you use now? Because the interesting part is here that there are actually people crossing, like Windows 95 actually. That's fun. Right. That's a Gopher, the Gopher routine. And also, every time people sort of bring up the, well, what do we support Gopher for? Shouldn't we remove it? It's very, very easy to support Gopher because nobody's using it, right? So nobody's complaining about it. There's no bug reports file. It's you know, that's a dusty old corner that nobody goes to, and we don't have to clean that corner because nobody is there. Nobody cares about it. So it's really, really easy to support Gopher. It doesn't hamper anyone. It doesn't hurt anyone. It's no burden to carry on. And most of the protocols in curl are like that. Most of those, you know, people never use them. They're very, very rarely support burden to us. They're just there. Nobody cares about them. Not the users and not the developers. And sort of that goes hand in hand because the ones that people are using, those are the ones people are finding problems with, and those are the ones people are adding features to, and that's where all the focus is for development. So it evens itself out, right? So we're working primarily on the protocols where people are actually, the protocols people are actually using the most, like HTTP, HTTPS, FTP, and the SSH-based ones, SFTP. So that's also why it's pretty easy to actually support all those 24 protocols. And you know, I like to keep track of some even numbers in this project. We actually turned 8,000 days old 20 days ago. I blogged about it. 8,000 days it doesn't really mean anything. Otherwise, that is sort of an even number when in decimal. But we're also turning 22 years old in 16 days. So on March 20, 2020, we're turning 22. And I have this awesome blog post coming, which I hope you will enjoy. 22 graphs from our 22 years with 2,222 words. So I've dug up a lot of data and graphs of the curl development over the 22 years we've existed. And it'll be fun. A lot of things have grown a lot over the years. It will include CI jobs over time. Yes, that's one of my most recent graphs actually. We started out with 2 CI jobs in 2013, and we actually had 2 CI jobs for a very long time on GitHub. And we are on 72 now, I think. And also at the same time, we increased the number of CI jobs over the time, and we also increased the number of tests over time, right? So we're not only sort of growing the number of CI jobs really fast, we're also doing more jobs per CI job over time. So it's nowadays it's actually a crazy amount of CPU we spend on every pull request. I think we're around 30 CPU hours or so per commit, which means we're on I think we're around 300% of CPU, I mean around the clock, just doing CI or testing. Is that climate-wise? Maybe not. Well, you know, bug reports have the same problem as the surveys, that the bug reports only reports one user having one issue, right? It could be the one user running an application used by 2 billion humans, and that could be a significant user. Or it could be one user who had one problem once with one user in a basement somewhere, and it's really never affected anyone. So bug reports doesn't really say much about the state of things either. Also because bug reports only says about the particular user that had a problem. It doesn't say anything about the billions of users who had no problems at all and are just happily, you know, downloading the internet every day anyway. Well, of course, CI jobs affect the climate. They do. I mean, since they spend power, right? So it's not done for nothing. But you could also argue that making sure that we actually ship good curl is good for everyone, and it's, when we have a good, curl is used in the billions, I think it's more of a net benefit to have it. A better curl saves a lot of time and efforts and CPU for a lot of people, so I think it's actually a net gain to have a better curl. So I actually think it's actually a benefit for climate to spend more on CI in curl. But of course, that's an argument to be had, and you could argue the other way around, of course. So I'm on 1 hour 10 minutes. I'm going to call this a day and go and have a coffee refill and celebrate this release. That's the benefit with doing the releases early in the morning in a workday. No particular beverages. Actually, I have this release procedure document that says how to do a release in curl, and it actually says, I have carefully added a little point there about the obligatory celebrationary drinks. So everyone, coffee refill now and celebrate curl 7.69.0. Will we ever get to version 8? Yes, we will, but more about that another time, because there's no real plan to do it. So at one time we will just bump it to version 8 and be happy with it. I could have an extra special stream at that time. Okay. Let me know if you have any questions. We'll do another stream another time. Have a great Wednesday. Bye.